team. We'll give it 1 more minute, then we'll be able to give it to James to kind of continue with this. So enjoy the music. One last song, then we shall start. Great. Hi guys, hope you're well. My name is Mark Orina. I'm part of the organizing team of AWS User Group with Adeline, Tony, and Samuel. And really happy to meet you guys this, I think, is it the last week of Thursday, or of February? Excited to see you guys. Hopefully you guys are psyched up for today's presentation. Our presenter today is James Sindani, student at Jomo Kenyatta University, still doing really good stuff in the cloud space. Really excited to have him here today as he takes us through designing 3-tier architecture, I think, within AWS Cloud. Hopefully you'll really have fun and learn from there. As we go on, I'll also share our links on how you can join us and just be part of the journey as we go on. Other than that, I'll let James kind of do his introduction himself, who he is, what he does, and the other really good community that he actually runs. I've seen a few of them here, Barasa, ZP, I think I saw also Nyambate here and a few other people. So James, if you don't mind, you can take it up. He'll do the presentation. And once we are done, we'll kind of have a bit of a debrief before we close it for the day. Okay, thank you very much. Before I start, maybe I'd like to do a poll in the room. How many people are joining from Nairobi, like just within Nairobi here? So you can just put like a +1 on the chat if you're from Nairobi or other than Nairobi. So just on the chat, just put a +1 and just see you guys who are from Nairobi. And also if let's say you're outside Nairobi, you can do a +2. Then we just see how many people are from, some other places. So Nairobi +1, outside Nairobi +2. All right, cool. So James, you can go on as we go as we do this. James, everyone.
Awesome. Thank you so much, Mark, for that introduction. And at this point, allow me now to share my video so that I can save on bandwidth. Nice, thank you. So to the audience, thank you so much for finding time to come and listen to me. And as Mark has said, James Juma Sindani. And the first thing is I'm a student. I'm pursuing a course in telecommunication and information engineering, that is in JKUAT. But apart from that, I'm also a solutions architect at a company called Silicon Overdrive, which is located in South Africa. And what I do is I work remotely for them. And apart from that, also I'm a co-founder of a community called Resource Cloud Academy, which is made up of young tech enthusiasts who will wish maybe to start or advance their career in cloud. Yeah, and so majorly that's me. I live in Nairobi. I'm currently in Nairobi and all that. And I love traveling. I love going to the gym and having great times with my friends and close relative. Yeah, so that's just a brief description of who I am. And today, our main topic will be centered around 3-tier architecture. And as you've heard from my introduction, I said I'm a solutions architect, and to be specific, I'm an AWS solution architect. So maybe just a brief introduction on what I do as a solutions architect. Basically, our main day is interaction with interaction with customers and clients all over Africa. And what we do is first introduce the customers to our company, and after that is the work of the solutions architect led by our lead to drive the conversation. And what do I mean by driving the conversation? after the initial introduction by sales, the customer will get to the pre-sales. What we do is for us, as solutions architects, they fall under the pre-sales department. Now, after the salesperson has introduced the customer to the pre-sales, we are going to um, further on the conversation with the customer so that we can just try to identify what is their main problem. Why do they want to migrate maybe to AWS? And after getting to that conversation, we go ahead and design an architecture diagram for them. After that, we do some documentation of all the services that will be involved in that migration to the cloud. And after that, it's when we get back to the customer with the documentation, with the diagram, we do a presentation to the customer. And once the customer is okay with what we came up with, we send our design, we send our documentation to the engineering team to implement what we will have drawn in the diagram and came up as the documentation. And now today, I'm going to take you guys through how to design a 3-tier architecture on AWS so that it be ready for implementation when it comes to the engineering team. And so at this point, just allow me to share my screen so that I can take you guys through a typical customer scenario from sales, and we can go ahead and dive deep into the session by coming up with the design diagram. So just 1 minute as I share my screen. And kindly let me know once you've seen my screen. Hey, Mark, can you see my screen?
Yes, we can see your screen.
Awesome, awesome. Thank you for that. Now, I'll just take you through what is written here. As first, I told you the first point of contact is the sales. So the sales will get into a meeting with the customer and try to analyze their main problem so that they come up with a documentation that will drive the conversation further. So from our typical scenario here, I used AWS User Group. Let's say AWS User Group is a company that provides an e-commerce platform for small businesses. The platform provides businesses with an easy-to-use order management system that enables them to track and manage orders, fulfill orders, and manage returns. This can include features such as order tracking, shipping integration, and real-time inventory management. AWS User Group's current system is running on a single server, which is being overloaded with traffic as the platform gains popularity. So from the sales note, we realize that the first problem that these customers are experiencing is the overload in terms of traffic. Thank you. Let's proceed. The second one is that the company is also concerned about the reliability of the system, as any downtime could mean lost sales and revenue for its customers. Okay, that's well noted. They are highly concerned about the cost that will come with having their workload on the cloud. Now, moving forth to the technical discovery notes. Now, when you talk of technical discovery notes, this is where the pre-sales team comes in. They get into the meeting with the client and try to have some specification in terms of what is their tech stack, in terms of the programming language that they have used to build up their platform, what are their specification in terms of maybe memory, storage, and CPU of the application and all that. Now, for the tech stack, the front end, which typically most of people know this as UI, it's built using HTML, CSS, and React to build the user interface and provide a more responsive experience for the user. Then you have the application layer. This is the middle tier. The application of the platform is built using a server-side programming language that's Node, and the application communicates with the database to retrieve and store data. Remember, this is the middle layer that acts as a bridge between the front end and the database. And finally, we have the database. The platform is using a relational database management system, the Postgre, to store and manage data. The database is responsible for storing data such as customer information, order information, product information, and other e-commerce related data. Now, from that conversation, we can come up with our main pain points. And one is the overload of the server, which is mentioned here. They want to cater for that. They want to overcome that problem. So the problem is the current system is running on a single server, which is becoming overloaded with traffic as the platform gain popularity. Nice. The second pain point is a reliability concern. They don't want any downtime, as this means loss in terms of revenue. Then the third one is scaling limitation. The current system is not designed to scale efficiently. Remember, if it's on-premise, they probably have all these layers on one single server, meaning it's very hard to scale. It's very hard to get to maybe, let's say, um, more computing platform unless you have to purchase a bigger server. So that's the limitation that they got, and that's why they want the application to be migrated, because we know in cloud there's that benefit of pay as you go. You only pay for the services you use, and you have this capability of scaling to any compute and any storage and any RAM that you wish. So that's one reason why they want to migrate to cloud. And now we recommended to them to migrate to a 3-tier architecture. A 3-tier in a sense that their one server will be broken down into 3 different tiers: the presentation tier, the application tier, and the data tier. So let's just have a brief introduction and explanation of what a presentation, application, and data tier are. And the presentation tier, which is commonly referred to as a user interface, is the topmost layer of the application, which is responsible for handling user interaction and displaying information to users. That's the front end part that maybe, let's say, when you want to interact with an application such as YouTube, the front end is that presentation tier. What you are able to see is the presentation tier. Then the second tier is the application tier, which is also known as the business or middle tier. And as I mentioned earlier, this is a bridge between the front end and the database. So this tier it includes components such as server-side scripts, application servers, and APIs that provide an interface between the presentation tier and the data tier. Remember, presentation tier, we said it's the front end. Data tier, it's the layer that we'll talk next. The application tier processes user requests from the presentation tier, retrieves or manipulates data from the data tier, and sends the response back to the presentation tier. So it's kind of a bridge between the data tier and the presentation tier. If the presentation wants to interact with the data tier, it must first go through the application tier. The same way, when data tier wants to send information back to the presentation, it must link with the application tier. Then finally, we have the data tier, and it's also known as storage tier. And this is the lowest layer of the application. It's responsible for managing and storing the data used by the application, and it includes components such as database, file system, and other storage mechanism. Yeah, so that's generally what a 3-tier architecture looks like in terms of the tiers. And overall, the 3-tier architecture model provides a and flexible approach to application development, with each tier having a specific role and responsibility, making it easier to maintain and update the application functionality. Now that we've had a look at the customer scenario, it's a high time we get to design part. And as a solutions architect, there are 3 main tools that you will interact with them each and every day. One is the platform that you use for designing. That is, I think it's called Draw.io, but they have named that to diagrams.net. So if you search for Draw.io on the internet and you don't find that, just know that it's been named to diagrams.net. So that's the first tool that you need to be aware of. The second tool is in terms of costing. Remember, the customer will want a full report with the services that are going to be used, but also additionally, they will want the monthly cost towards the end of my presentation. And the third and last tool is documentation. And this is what you need to find a way of explaining to the customer what you've drawn in terms of the diagram, what you've done in terms of the costing, and if there are professional services, definitely they will be there for the migration. You need to account for that, and that is done in the documentation. Because remember, you need to do all this, you need to have the document, and you need to send it to the customer or client before sending the information to the engineering team to implement, okay? Yeah, so given that we've gone through this scenario, let's dive deep into the session by now going to the Draw.io and designing our 3-tier architecture. So let me just stop sharing and share another screen. Just a moment. Nice. Mark, kindly confirm that you can see my other screen. It should be showing a different.
Yes.
Awesome, awesome. Now, okay, this is the diagram that I want us to design from scratch, and at the end of it all, we need to understand what has been designed and how we've come up to this conclusion. So at starting point, let's just this will use as a reference, but let's just have our own space and deep into this. And so to start us off, first we need to understand their infrastructure while the application is still on premise. So I'll just come up with okay, a diagram to represent what they are currently hosting and how the diagram will look like when they migrate to AWS Cloud. So, okay, we can start with let's draw a square, not a color, sorry. Right. So this is, we're trying to implement what is currently on their on-prem. Yeah, so let's just say this is the web, this is the web application, the web server. This is the application server, which is the middle tier. And finally, we have database. Sorry. Database. And remember, just a moment. Remember, all these are on one single server, okay? So let's just rename this to their on-prem, like that, to just show that it's on one server, but they have logically divided it into web server, application server, and database. And for this one server, we need extra information such as this information will help us to design a solution that will be workable to them, such as VCP, memory, and finally the memory and the storage. Now for the on-premise, let us do a general assumption that they are using, let's say, 4 vCPUs, 16 Gs of memory, and let's say 100 GB of storage. Yeah, okay, so 4 vCPU, 16 GB, and let's go with 100, not 200, 100. Yeah. So this is currently what their on-premise environment looks like. The web server, application server, and database all in one server with the following specs: 4, 16, and 100. And this we need to implement it on AWS. Now we are going to how the process of migration will work. Like, remember, we've said at 3-tier, we are going to separate all this into 3 different servers. Okay, so that's the first point. And in AWS, you know that a server, it's called an EC2 instance. So what you're going to do is we're going to start with the web server. We create an EC2 instance of our web server, put it inside a subnet, and so on and so forth. So let's search for EC2. The goodness with this tool is that when you search for a service, near time you get it in this result. But if you don't have an icon for that service, you can export it directly from the internet. So that's the flexibility that comes along with using Draw.io. Yeah, so for this, let's use this icon. Sizing, let it be 50, and let's name this to our web server. Okay. Yeah, now this is the web server, and also we need to identify the type, the operating system that will be installed that will be running. So let's for us it was Linux. Let's search for the Linux icon and go with, yeah, this one looks better, but let's just maybe change the coloring of it so that let's put just a moment. Yeah, so let's try to make it fit inside here. Yeah, so that's our web. Let's try to make it a bit smaller. Let's go 20 by 20. Yeah, so as an architect, you need to make sure that almost everything you do is centered, so that a Linux, an EC2 web server which has a Linux as its operating system as a web server. Now, given that we have the web server, remember it needs to sit in a subnet. So the next point is getting to our subnet, and I'll go with the private subnet. I'll tell you why, because remember, let me just undo. Remember, we can also install a NAT gateway if we want this our server to interact with the internet. So the best thing is putting this in a private subnet and having a NAT gateway on a public subnet. So okay, let's send behind. Let's do this and to back. Then we can do this. So to just make sure everything is centered there. Then you can name this private subnet A1. Sorry about that. You can name this to private subnet A1. That's it. This is still not centered. Let's try to center this. Nice. Okay, so that's our web server. The next one, we go to application server. It will all be EC2 instance. So what you can do is we can just duplicate this diagram. We duplicate it. Then let's move it a bit lower. Make sure it's aligned. Let's name this to private subnet A2. A2, nice. Then we name this to application server. Oh, sorry about that. Let's just have a short form for it. App. Let's call it app server. Nice. Now we have the web server, we have the app server, we are left with the database. Okay, so we can also duplicate this. Nice one. Let's name this to, oh, sorry, this should be A2, this should be A3. Nice. And okay, so for the let's make sure it's 50 by 50 and place it inside there, and then this will be our master. Yeah, and then I will create slave later on. Oh, okay, at least we're getting somewhere, because compared to what we had, at least now we've broken it down. Sorry, let's Control Z. We broke it down three into a 3-tier architecture. As you can see, we have the web server, application server, and the database. But now this has just solved one problem of being able to work on the web server, application server, and database separately. But what about making sure that this system is reliable, making sure that at no point we are going to experience downtime, at no point you're going to hear that our server is down. And that can be done when we enable TSZ deployment. That is having this application to a different availability zone. Okay. So what we'll do, this all will be in one availability zone, and for high availability, we're just to duplicate this and put it in a different availability zone. Okay, so that this can be availability zone A, this will be availability zone B for available environment. So let's just push our architecture a bit down. Just a moment. Yeah, so let's work with that. Yeah, so we have, let's maybe just rename this to B. Let's B, and finally B. Nice. Now we have the servers, they are across 2 availability zones. But now what of scalability? What of maybe if at a particular point when we have too much traffic on this server inside this availability zone, we need to find a mechanism where we can allow this mechanism to deploy another server so that it can reduce the load on this web server. What I'm to explain is auto-scaling group. We need to have an auto-scaling group spanning across these availability zones, so that with this auto-scaling group, we can have a minimum, a maximum, and a desired value. At a minimum, let's say at a minimum, we want 2 EC2 instance to be always running. At a maximum, 5. Desired one, let's say 2, okay? So that will be the work of the auto-scaling group to enable that our application is going to scale according to traffic being experienced. So we'll just look for the icon of auto scaling. Yeah, and let's use this. Then we can just drag it neatly to be between these 2. Yeah, then let's just modify it a bit, so that to show that it's spanning across these 2 availability zone. The same thing you're going to do for the application layer. So let's just have that here. So as you can see, our design is coming up slowly. Nice. And also we need to make sure that we've told the customer this is a managed service. So we just need to look generic group, try to group. Let's see, let's use this. Let's just remove this name, generic. Try also to align it at the center. Then I have it this way. Just a minute. Yeah, nice. Then we need to also look for the icon, so that we can just show to this people that this is a managed service, and it's being managed by RDS. nice. Then we can just rename this to this.